Hello friends, in this video we see the proof of Chinese remainder theorem and its example. Let's see the statement of Chinese remainder theorem. Let n1, n2 up to nr be positive integers such that GCD of ni and nj is equal to 1 for I not equal to j. Then the system of linear congruences x congruent to a1 modulo n1, x congruent to a2 modulo n2 up to x congruent to ar modulo nr has a simultaneous solution which is unique modulo the integer product of integers n1 n2 up to nr. Note that the system of linear congruences contains r linear congruences and we are getting a solution of this system of linear congruences which is unique modulo the integer n1 n2 up to nr. Let's see the proof. Let small n is equal to n1 into n2 up to nr. Let capital Nk is equal to n by small nk for each k from 1 to r. Since GCD of small n and small nj is equal to 1 for I not equal to j, GCD of capital Nk and small nk is equal to 1 for each k from 1 to r. So, by the theory of linear congruences, the linear congruence nk into x congruent to 1 mod nk has a unique solution, say small xk. Let x bar is equal to a1 into n capital N1 into x1 plus a2 into capital N2 into small x2 plus up to ar into capital NR xr. Note that capital Ni is congruent to 0 modulo small nk for I not equal to k, since small nk divides to capital Ni for I not equal to k. So it implies that ai into capital Ni xi is congruent to 0 modulo small nk for I not equal to k. And so it follows that x bar is congruent to ak capital Nk small xk modulo nk for each k from 1 to r. And since capital Nk into xk is congruent to 1 modulo nk, as small xk is the solution of linear congruence nk into x congruent to 1 modulo nk, x bar is congruent to ak modulo nk for each k from 1 to r. And it implies that x bar is a solution of the given system of linear congruences. Now we prove the part of uniqueness. Now we prove that x bar is a unique solution of the given system of linear congruences modulo n. Note that n is a product of n1, n2 and nr. Suppose that y bar is also a solution of the given system of linear congruences, then by the definition of solution of system of linear congruences, y bar is congruent to ak modulo nk for each k from 1 to r. So it implies that x bar is congruent to y bar modulo nk for each k, since x bar is congruent to ak modulo small nk for each k. So it implies that small nk divides the difference of x bar and y bar, means nk divides x bar minus y bar for each k, but GCD of ni and nj is equal to 1 for I not equal to j. So it implies that the product of integers n1 into nr divides to x bar minus y bar, but this product of integers n1 into nr is nothing but n, so n divides to x bar minus y bar. And so by definition of congruence modulo n, x bar is congruent to y bar modulo n. And hence the given system of linear congruences has unique solution modulo n. N is nothing but product of integers n1, n2 up to nr. So this completes the proof of Chinese remainder theorem. Now we see one example. Now we solve the system of linear congruences x congruent to 1 modulo 3, x congruent to 2 modulo 5, and x congruent to 3 modulo 7. Let's see its solution. Let n is equal to product of 3, 5, and 7. Here we can see that small n1 is 3, small n2 is 5, small n3 is 7. So n is product of integers 3, 5, and 7 means 105. Let capital N1 is equal to n by 3, which is 35. Capital N2 is n by 5, which is 21. And capital N3 as n by 7, which is 15. So we can see that the linear congruences 35 into x congruent to 1 modulo 3, 21 into x congruent to 1 modulo 5, and 15 into x congruent to 1 modulo 7 are satisfied by small x1 is equal to 2, small x2 is equal to 1, small x3 is equal to 1 respectively. Note that the 35 is nothing but n1, this 21 is n2, and this 15 is n3. Take small x bar is equal to 1 into 35 into 2 plus 2 into 21 into 1 plus 3 into 15 into 1. You can see that here this small a1 is 1, small a2 is 2, small a3 is 3. Capital N1 is 35, capital N2 is 21, capital N3 is 15. And here this 2, 1, and 1 are nothing but solutions of this linear congruences, which is x1 equal to 2, x2 is equal to 1, x3 is equal to 1. So x bar is equal to 70 plus 42 plus 45, which is nothing but 157. But we can see that 157 is congruent to 52 modulo 105 because 157 minus 52 is 155 and 105 and 105 divides to 105. So x bar is congruent to 52 modulo 105. Hence 52 is the required solution of the given system of linear congruences. Okay. Thank you for watching the video. Please subscribe the channel for more such videos. Thank you.